Welcome back, everyone. Today we're going to be doing our second and final lesson for this first week, and you'll find it in section 2.2. And it's a continuation of what we did before, where we were finding the sides that were missing in right triangles. Now we're going to be finding missing angles in right triangles. So what you're going to need to do is you're going to need to use what's called the inverse button. And the inverse button is on top of your sine, cos, or tan buttons. And those are the -1 keys. So if you see your regular sine, cos, and tan on top, you'll see that there's sin with a -1 exponent, cos with a -1 exponent, and tin with a -1 exponent. So those are the keys you're going to need to use, and they're second function keys. So whether you have a shift or a second function, that's what you're going to have to press, and then the sine, and then the cos, and then the tan in order to get the angle. So if I asked you, what is the angle? See here how it's a capital? What is theta, or what is the angle A? That would create opposite over hypotenuse. That works out to be 0.6820. So in your calculator, what tends to happen is you go shift, in this case sine, so second function sine, and you should see that. And you're going to type in this number, 0.6820. And then you're going to press equals. And because you're in degrees mode, this 43 is the amount of degrees. The next one is tan of angle B is worth 0.4040. So we got to shift tan 0.4040, and that gives us 21.99. So we'll just call that 22 degrees when we round to the nearest degree. Cos, capital C, is 0.75, so we shift cos, and you go 0.75, and that gives you 41.4 degrees, so 41. And the last one here, tan of angle D is worth 0.8, so we got to remove the tan by going shift tan, so we inverse out tan, 0.8, so that means opposite divided by adjacent worked out to be 0.8. So that could be 8 over 10, for instance, or 4 out of 5. When we press equals, we get 38.6, so 38.7. And again, that's to 1 decimal place. So it depends on what the question's asking you, whether it wants the nearest whole degree or 1 decimal place. This one didn't say. Again, here we're solving for the indicated angle rounding to the nearest whole number. So that means no decimals. And they didn't put the little angle symbol there, so I'll put it in there for them. So sine angle A equals 4 over 5. So here they were giving us decimals. Here they're giving us fractions, but it's the same thing. So what you need to do is you need to show that you're kicking out the sign to the other side. So angle A by itself is that sine to the -1 key of whatever 4 divided by 5 is. So this is the way you write it down on paper. Then you pick up your calculator and you go 4 divided by 5. 4 divided by 5 in this case. Oh, come on. 0.8 again, of course, and you go then shift sign. So once you get the decimal of whatever that fraction is, that gives you your angle. So angle A is 53.1 degrees. Now it's set to the nearest whole number, so we're just going to call that 53 degrees then. So forget about the decimal one. Same thing over here. In this case, we need to kick out the tan to the other side to leave angle B on its own. So tan then becomes inverse on the other side. Bracket whatever 12 divided by 8 is. And again, in your calculator, 12 divided by 8 equals, shift tan equals 56.3. But again, when we're rounding, this is just 56 degrees, no 0.3. Okay, now we have pictures. So instead of them giving us the ratios, we have to figure it out ourselves using SOHCAHTOA because these are right angle triangles. So determine the measure of angle A. So inside the little corner where A is labeled, I want you to put a theta symbol. So that's the corner we're interested in. We're not interested in this one. It didn't mention this one. So this side is referred to as the opposite. And this side over here, since it's across from the 90 degrees, is the hypotenuse. So what has opposite and hypotenuse in it? Well, that's sine. So if you remember, that's your formula. Well, now we need to fill in what we know. Well, sine is just sine. That doesn't change. Theta is what we're looking for, so we don't know it. You could also call it capital A. Your choice, whether you put the theta symbol or the capital A. Opposite is 8.2, and the hypotenuse is 12.1, and I'm leaving off the centimeters. So just like we did up here, we're going to kick out the sine to the other side, and we're going to get theta by itself. So we're going to inverse sine of whatever 8.2 divided by 12.1 is. And it doesn't say how many decimal places to keep, so we'll just keep one decimal place. 8.2 divided by 12.1, get some decimal, and then we go shift sine, second function sine, and we get an angle of 42.7 degrees. Down here, determine the measure of theta. So again, theta is down here. This wasn't labeled, so let's label it for them, DEF, for instance. And again, that's where the theta is located, so this then is referred to as opposite. This side that we know as well is referred to as adjacent. We don't care about this side, it's not important in this question. So what trig ratio, sine, cos, or tan, has opposite and adjacent in it? Well, that's going to be tan in this case, so opposite over adjacent. Tan is just the operation, so that stays. Theta is what we're looking for. So again, you can call it theta or you can call it capital F, your choice. Opposite is 6 and the adjacent is 8. Kick out the tan to the other side of 6 over 8. And again, doesn't say how many decimal places to keep. 6 divided by 8 equals, shift tan equals 36.9 is what I see. 36.9 degrees. And you always put the degree symbol right after you get an angle. So when you go to the next page, it's only 2 pages for today, it asks us to answer, to solve a triangle, we have to obviously find all 3 sides and all 3 angles. You have to find everything that's missing in a triangle when you're told to solve a triangle. We looked at that in the previous lesson. So if you know 2 sides of a triangle, and it's a right angle triangle, they didn't mention that, the third side can be found using, remember, Pythagorean theorem. So in this case, we don't know any angles, but we have to solve the triangle, which means we have to find everything that's missing in this triangle. The order you find things in doesn't matter. So you have a lot of options. Why don't we get angle X? So for angle X, I know the opposite and I know the adjacent. So this would be a tan situation for angle X. So tan X, or tan theta, if you wanted to call it theta, equals opposite over adjacent. Solve for angle X by kicking out the tan to the other side. And keep one decimal place to your answer. So 32 divided by 24 equals inverse tan 53.1 degrees. All right. So now that I know that that one is 53, and of course I can label on my diagram, it makes sense to get angle Z, because we know that that's just going to be 180 minus the 90 minus the 53.1. And we get 36.9 degrees. So that one's easy. No trig required. So now I know all 3 angles, and I know 2 sides. So the third side, which I'll call little y because he's across capital Y, again, you have options. This case, let's do Pythag. Let's do small side squared plus small side squared equals hypotenuse squared. So 32 squared is 1024 plus 24 squared, 576. You're going to get y squared. Add those 2 numbers together. 1600. Oh, that's nice and easy. Then you square root, of course, and you get your 40. Check your diagram. Could this side be 40? And the answer is yes, because that's longer than the other 2 sides, and this should be the longest side of the triangle. In the end, it's always nice to say therefore. Angle X is 53.1 degrees. You summarize it for the reader. Angle Z is 36.9 degrees, and little y was 40, and it didn't give me units, so 40 whatever, centimeters. It's always nice to summarize when you found more than one thing. And also notice that I've numbered them, so it's easy for somebody to follow along in the order that I did it. All right, next one, similar situation. It doesn't tell you what to find first. So why don't we actually find little a first, which is the side opposite vertex A. Why not? And let's use Pythag. Again, small side squared plus small side squared equals longest side squared. 30 squared plus a squared is worth 34 squared. So that means a squared is going to be whatever 34 squared minus 30 squared is. And 34 squared is 1156 minus the 900. When we minus that, 256. We still have to square root, of course. And we get a nice number like 16. Could this side be 16? Sure, it's less than 34. Makes sense. Next, we have to find one of these corners. Once I find one, then I can find the other one very quickly. So let's find angle A. So I'm not going to use the 16 just in case I screwed up on my answer. So I'm going to go back and use the 30, which is the adjacent to angle A, and the hypotenuse, which is also given. So this is going to be cos of angle A is 30 over 34. Angle A by itself, we kick out the cos by inversing of whatever 30 divided by 34 is. 30 divided by 34 equals, shift cos equals 28.1. And last but not least, the third thing, angle C is equal to 180 minus 90 minus 28.1. And we get, of course, 61.9. So take the time to say, therefore, angle A was 28.1 degrees. Angle C was 61.9. And little a is 16 whatever centimeters. All right, so I'm going to stop here, and I suggest that you pause the video and try these next two on your own, and then come back and see if you did them right with me. All right. So again, F is on top, which is good, which means we just kick up the 8.5 to the other side, and we multiply with the tan 35 that's sitting there. So tan 35 times 8.5, and in your calculator you get 5.95. So if you round up, that 5 causes the 9 to become a 10, which you carry the 1 over, so it's just 6. So 6 centimeters in this case. So there you go. So that's the end of 2.2. So again, you're going to find your practice located in your practice booklet under 2.2. And your practice begins, and it looks like this, where you're solving for the missing angles, either in decimals or in diagrams. And it goes up to 4 questions on the 2 pages, plus some on the back with your solutions down below. So it is important that you give these a try. And again, ask me any particular questions that you might have. All right.